This is a box. But it isn't just any box. Engineers call this the black box of artificial intelligence. You probably use AI every single day, maybe to summarize your homework, generate a weird image of a cat wearing a tuxedo, or translate your 2 a.m. thoughts into another language. But here is the weird part. If you ask the scientists who actually build these things how they work, they usually look at you and say, honestly, we aren't 100% sure. Wait, what? How can humans build something this powerful without actually understanding the why behind its decisions? Well, today we are going to crack that box open. We are going to look at the gears, the math, and the massive wave of numbers that is pretending to be a human brain. To understand AI, you first have to realize that machines are actually incredibly stupid. They don't have eyes, they don't have ears, and they definitely don't have feelings. To an AI, a picture of a cat isn't a fluffy animal that likes to sleep in the sun. It's just a giant, overwhelming grid of numbers. If you zoom in far enough on any digital image, it's just pixels, and each pixel is assigned a number based on its color and its brightness. This is the only reality an AI knows, a tsunami of digits. When you give an AI an input like a photo of a dog or a text prompt about the moon, it feeds those numbers into the first layer of its neural network. Think of this like a wall with millions of tiny light switches. Some flip on, some flip off. This is the input layer. But the real magic or the real mesh happens in the middle. These are the hidden layers. In 2026, a modern AI model doesn't just have one or two of these layers, it has hundreds, sometimes thousands. As the data moves through these layers, the AI is essentially playing a high stakes, lightning fast game of connected dots. But it's doing it at a scale that the human mind can't even begin to visualize. In the first few layers, the machine is looking for basic stuff. It scans the millions of numbers and identifies straight lines, sharp edges, or tiny dots of light. It doesn't know what these lines are for. It just knows they exist. It passes that information to the next layer, which starts combining those lines into curves and angles. By the time the data reaches the middle layers, the AI starts to recognize more complex shapes, circles, triangles, or squares. But it doesn't stop there. As the data travels deeper into the black box, the features become incredibly specific. One layer might specialize in recognizing textures, the roughness of a brick wall, the coldness of metal, or the softness of fur. Another layer might focus entirely on spatial relationships, calculating exactly how far apart two eyes should be on a face to make it look human. By the time the data reaches the final layers, the AI isn't looking at pixels or lines anymore. It sees pointed ears, long whiskers, and a wet nose. But here is the kicker: the AI still doesn't know what a dog is. It doesn't know that a dog is a loyal friend or that it likes to chase squirrels. It just knows that in its massive database of billions of photos, the specific mathematical pattern of pixels has a 99.9% probability of being associated with the human label dog. It isn't thinking in the way you are thinking right now. It is predicting. It is a calculator that has effectively memorized the entire internet and is now using extreme statistics to guess what you want to see. Now, how does it get so accurate? This is made possible by something called weights and biases. Think of these as billions of tiny volume knobs inside the AI's brain. When an AI is being trained, it is basically a baby. It makes trillions of mistakes. It sees a photo of a golden retriever and guesses toaster. When it gets an answer wrong, a mathematical process called backpropagation kicks in. It goes all the way back through those thousands of hidden layers and adjusts the knobs. It tells the neurons that were wrong to quiet down and tells the neurons that were right to speak up. The system does this over and over again for months using massive supercomputers until the math becomes so fine tuned that the predictions look like real breathing intelligence. But because there are billions of these tiny knobs, each one set to a specific decimal like 0.1742, a human can't just read the AI's mind. If you look inside the box, you don't see ideas. You don't see a thought about a dog, you just see a mountain of math that is too big for any human to navigate. That is why we call it a black box. We know what goes in and we can see what comes out, but the why is buried in a mathematical maze. This also explains why AI fails in such hilariously weird ways. You've probably seen the images: people with six fingers, three legs, or eyes that seem to be melting into their foreheads. Why does this happen if the AI is so smart? It's because the AI lacks a fundamental understanding of logic and biology. It doesn't know that a human hand must have five fingers for a reason. It doesn't understand the skeleton or how muscles work. It only knows that in the billions of images it saw, fingers usually appear in clusters near palms. If the statistical math suggests that another finger should be there to complete a pattern, the AI draws it. It lacks a sanity check because it doesn't live in the physical world. It lives in the world of probability. The same thing is happening with large language models like the ones you talk to every day. When you ask an AI a question, it isn't knowing the answer. It is playing a game called Predict the Next Word. It has read nearly every book, article, and tweet ever written. If you type, "the sky is," the AI's math says there is a 99% chance the next word is blue. It isn't looking out a window. It is just calculating the most likely sequence of letters based on human history. It's a simulation of a soul built out of data. This brings us to the big question of 2026. Is it going to take over the world? Is the black box going to become our master? Probably not yet. Despite how impressive it looks, AI is still just a tool. It's a very, very sophisticated paintbrush. It can paint incredible things we never thought possible, but it still needs a human to tell it what to paint and why it matters. It has no goals of its own. It has no desires. It only has the patterns we gave it. The black box is essentially a mirror of us. It reflects our knowledge, our creativity, and unfortunately, our biases and mistakes. It processes our entire civilization through a lot of math and hands it back to us in a way that feels like magic. But magic is just science we haven't explained yet, and AI is just math we haven't fully mapped. So the next time you use an AI to generate a picture or write a story, remember what's actually happening. Millions of tiny switches are flipping, billions of volume knobs are turning, and a giant wave of numbers is trying its best to guess what a human would do. It's not a ghost in the machine, it's just the most complicated calculator ever built. Anyway, that is how AI actually thinks. It's weird, it's messy, and it's mostly just a lot of multiplication. If you like this deep dive, hit that subscribe button so you don't miss the next explanation. We've got a lot more boxes to open. Let me know in the comments what we should unbox next. Is it the mystery of the dark web, the physics of a black hole, or maybe how your phone is actually tracking you? Whatever it is, we will explain it simply. Thanks for watching.